Hello, I am here in a coding challenge, and this coding challenge is a follow-up on a previous one where I looked at something called the traveling salesperson problem. Now, I would suggest if you didn't watch those videos, they're linked in this video's description. Go watch those, find out what the traveling salesperson problem is. But just quickly, just in case you don't, what the traveling salesperson problem is you create a set of points, cities, in a two-dimensional space. It could be three-dimensional, it could be four-dimensional, but in this case, two-dimensional. And you try to find what is a path that connects every possible city, starting from any city, ending with any cities, that is the shortest path. What is the easiest way to visit every single city and get to every single one? What's the shortest path through all the cities? Okay, so this particular program, which I did in the previous coding challenge, is looking at every single possibility. And even just with 1, 2, 3, 4, 5, 6, 7 cities, it's taking quite a while to check every possible city. It will get there eventually, not every possible city, every possible order. But if I just go and change this to like 10, this is really just never, ever, it will finish at some point. If I change it to 11, 12, there are 10 factorial possibilities with 10 cities. 11 cities, 12 cities, 15 cities. So is there a way we could do better? So the strategy I'm going to look at here is using a genetic algorithm. So these are the traveling salesperson previous videos that I would recommend you take a look at. And if you haven't seen or looked at any of, or don't know what a genetic algorithm is, then I would recommend this particular playlist. So this video that I'm making is not on this list right now, but it will be in the future. When you are watching it, it will be there. It's not there now. Oh, but like it is now because you're watching it. Anyway, okay, never mind. What was I saying? Yes. So this is going to go in this playlist. So if you don't know what a genetic algorithm is, I'd recommend maybe you check out some of these videos first and then come back. But I'm just going to start programming this straight away. So the idea of the genetic algorithm is what I want to have is a population. So right now I'm checking, I have this idea of an order, which is an order through all the cities. So I'm just going to use the code I had from the previous coding challenge and just start from there. And hopefully this is going to work. There's a bunch of stuff I'll be able to get rid of. But one thing I need is a population. So in the population, I need a population of many orders. So what I'm going to do now is I'm going to create that population. So so a couple things I don't need. Let's get rid of some stuff. I don't need this total permutations or count. Let's just get rid of this stuff. I do want to keep track of the best ever. I don't need this individual order anymore. There's not just one. So I have the cities. I have the total number of cities. Let's reduce that to 5 so we can see if it works more easily. And I have a population. OK, so I need to create the cities first. So first I create the cities. Now what I need to do is I need to create the number of the population. So let's just start with 10. So population index I equals what? So how to do this? So one way that I could do this is I could create, I'm going to create actually a variable called order right here, which is just order index I equals I. Okay, what am I doing? Okay, so the idea is that I have an array that keeps track of all of these vectors. That's called cities. Now what I'm going to do is I'm going to create an array called order. And what I want is just to have an order of how we're going to go through all those cities. And so I can start with just this, right? So if there are 5 cities, 0, 1, 2, 3, 4. Now my population, the idea of the population is I want to make a whole lot of these. And I want them to be random. Oh, no, they can't have 0, right? I can only have one number. I think I did. So how do I create a whole bunch of random configurations of this? Well, I could start with this regular order, and then I could just shuffle around elements a bunch of times to randomize it, kind of like shuffling a deck of cards. So let's do that. So this is just the standard order. This array is just 0, 1, 2, 3, 4. And now population is going to be order slice.slice. I'm pretty sure the slice function in JavaScript is a function, you can use it, you can give it arguments to slice out a part of an array into a new array. But what I'm doing here is I just want the whole thing. So it essentially makes a copy of that array. So if I just did this, right? If I just said population I equals order.slice, and I said console.log population, let's go to the browser, oops, and let's run this. Okay, what's not defined? There's lots of other stuff but I can see here that, look at this, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. That's what I've got. So what I actually want to do, stop, go away. What I want to do now is I want to shuffle it. So how do I shuffle it? Well, should I make a separate function, shuffle population index I? Why not? So I'm going to create a function, and there's probably, I wouldn't be surprised if there's an array function that does shuffling. Maybe not. Or we could add it using prototype. But anyway, I'm just going to write my own function. So I'm going to go down here to the very bottom. I don't need, this is something from the previous example that I don't need anymore. I'm looking for the swap function. Where is the swap? Here it is. So what I'm going to make use of this swap function. So my shuffle function is going to receive an array. And why don't we give it like a number? Shuffle 10 times. So like shuffle the deck 10 times. So I'm going to say and so this is num. For var I equals 0, I is less than num, I plus plus, var, so let's use n, because what I want to do is I want to pick two elements. I want to say pick a random index, and you know what, actually we can use I. And then I'll just say this is like index 1, or index A, is a random index into the array. And index B is another random index into the array. And then all I need to do is say swap array index A, index B. So the idea is that I shuffle by saying 10 times swap 10 spots in the array, or 100 times, or 1,000 times. So now, if I were to come back up to the beginning of this program, there's all this extra stuff that I don't know what I'm going to do with here, so I'm just going to comment it all out. What I'm going to do here, and I'm going to comment this out too, is now, if I look at this, when I look at the populations, I should see them all as shuffled orders. Okay. P5 had problems creating the global function shuffle. There's a P5 function called shuffle. How interesting. Well, first let's see if my shuffle function worked. And that's the first one. Oh, it doesn't look like it worked. Okay, so what did I do wrong? Let's just make our own array. Did I not give it a number? Oh, I forgot to give it a number. I have to say shuffle a certain number of times. So shuffle 100 times. Let's try this again. And let's look at it now. There we go. So you can see these shuffled into random orders. So now I have a whole bunch of random orders. Perfect. Okay. Now, what do I want to do here? First I want to go look up, what's this shuffle function? Shuffle P5JS reference. Because maybe this does what we want it to do. Oh yeah, array functions, shuffle. Look at that, shuffle an array. Randomizes the order of elements in an array. Implements Fisher-Yates shuffle algorithm. So this is a much fancier, oh, and look at this, we're on this wonderful, this is a beautiful Fisher-Yates shuffle. This is a great tutorial by Mike Bostock, the creator of D3, with a different algorithm for shuffling an array, which is different than mine, but anyway, let's just use it. So let's get rid of let's comment out my shuffle function, and let's just leave the P5 shuffle function and see what happens. I'm going to run this again. Let's look at what we've got. Now they're not shuffled. Why are they not shuffled? Well, I have a feeling that what it does is it makes a new copy of the array. So actually what I want to do here is just say shuffle order. So I'm using the P5 shuffle function. I want to just take that array order, shuffle it into a new array, and put that in the population. Perfect. And now if we look at this, we can see, there we go. So both are good ways of doing it. Now I'm at the point where I have an array, and I have a population of orders, and I've shuffled them. Next step, I want to find the best one in the population. Okay. Actually, what I want to do is give each one a fitness score. Okay, so I could do some kind of like object-oriented programming here where I create a wrapper object that stores the order and its fitness. But for simplicity right now, I'm just going to create another array called fitness. And so for every element of the population, I'm going to put a fitness score in the corresponding spot in that other array. So what I'm going to do is now I'm going to loop through the entire population. And I'm going to say, first I need to say, what is that distance? The distance is, and don't I have a calc, from my previous example, I have this calc distance function, which is right here. So this calculate distance function already calculates the distance of an array of points in a given order. So that's perfect. I don't have to add that code again. I already have that from the previous coding challenge. That's really nice. So I'm going to say d equals calc distance cities in the particular order of the population. And then I'm going to say fitness index I equals that distance. Now that's not exactly right, because I'm going to have to do some mapping to the fitness, because a smaller distance is a higher fitness. But let's just leave that for right now. And let's also, we have this idea of the best ever record distance. So I'm going to start with the record distance as infinity. And while I'm doing that, I'm going to say, if distance is less than record distance equals that distance, and best ever equals population index I. That particular order. OK, great. So now I'm going to take out this. Let's put all this draw stuff back in to sort of see the best ever. I'm going to leave the shuffle function, the swap function, calc distance. And now let's see what happens. Let me run this. OK, order is not defined, sketch.js line 46. OK, so this I don't need. I just want to look at the best ever. So, so I could say, this should say best ever dot length, sorry. And this should say best ever dot length. Whoops. I don't need two of these. Sorry, I'm just going to, there's all this extraneous stuff that I don't need. So I'm going to take all this out. So I just want to draw the best one. So you can see it's making however many and drawing the best one. Now, interestingly enough, if I were to increase the population size to 100, it's probably just out of 100 possibilities. What's 5 factorial? 5 times 4 is 20, times 3 is 60, times 2 is 120. So there's only actually 120 possibilities in here. But if I were to make the number of cities something like 10, and I just have 100 possibilities, you can see it got something better than just a random order, but this is clearly not the best order. OK, so one thing I want to do right now, just because I'm seeing things starting to get, as I already have all this code and I'm adding new code, I'm going to create a new JavaScript file. I'm just going to call it GA for genetic algorithm.js. And then I'm going to add a reference to it in my index.html file. And what I want to do is I want to take some of the stuff. I don't need this next order anymore function. This should go away. That was from the lexical order version. Calc distance, swap, these can all stay. But I want to have this other JavaScript file where I can start putting functions that are particularly relevant to the genetic algorithm itself there. So all I have so far, I know I just said this, but I got to recap this for myself, is I create a whole bunch of random orders. I try all of them out, and I pick the best one. So for the genetic algorithm to work, what I want to do is after I've done that, I want to generate a whole new set of algorithms, a whole new set of orders based on the orders that did better. So one thing that I need to do here is where I am calculating those distance values, and I'm actually going to take all of this here, and I'm going to make this in a function. I'm going to say calculate fitness. So this particular algorithm that goes through and assigns a fitness, what I'm actually going to do is I'm going to map the distance. that is a value between, the fitness is a distance that's a value between, what should I do here? What would be, so this is kind of an interesting thing to think about. You know what I'm going to do? I'm not going to do that. I'm going to invert it. So if I have a number, if I want to make a number that's a high number and make the higher it is, a lower value, the lower it is, a higher value, I can actually just say 1 divided by d. Now I could worry that d might be 0, and so I could say 1 divided by d plus 1. That way if d is ever 0, like the 0 being the absolute best distance ever, which is unrealistic obviously, because you're never, unless all the points randomly are right on top of each other, but then everything's going to be 0. But anyway, then the fitness would be 1 and everything else would be lower. So I'm going to add that in there just as kind of a nice little extra thing, and that's the fitness value. Okay, then what I want to do is I actually want to write a function called normalize fitness, because for the way that I'm going to pick them, what I want to do is, I'm going to mention another video that I made recently, is I want all of those fitness values not to be just some arbitrary value that's higher or lower, but I want them to map to a probability between 0% and 100%, and I want all of them to add up to 100%. So the way that I do that is I first need to calculate a sum, then I need to loop through the entire population again, and I need to say sum plus equals fitness index I. So I want to get the total fitness, and then all I have to do again, I can say fitness.length, because that's really the array that I'm working with, although fitness and population are going to have the same length. I'm going to then go through it again and say fitness index I equals fitness index I divided by sum. So this is the process of normalizing all those fitness values. Okay, so if I go back to the sketch, this is something I'm going to do every frame. So now I really have my genetic algorithm. The first thing I need to do is calculate fitness. Then I need to normalize fitness. Okay? So once we've done that, I've calculated fitness, I've normalized fitness. Now it's time to make the next generation. And I suppose I could draw the best before I make the next generation, but I'm not going to worry about order too much here right now. Okay, calculate fitness, normalize fitness, make the next generation. So how do I make the next generation? Okay, let's go back to here, and I'm going to write that function. Next generation. So I'm going to make another array. I'm going to call it new population. And what I want to do is I want to create something like this. I want to say, for every member of the existing population, make a new member of the new population. So if I have 100 to start, I want to then the next generation has 100, the next generation has 100. So just as a little experiment here, just to make sure things are working, I'm going to say new population index I equals population index I dot slice. So what if I this is like not a genetic algorithm at all. This is me just making an exact copy of the previous generation in the new population. And then at the end, I can just say, hey, guess what? Population equals new population. So make a new population that's a copy of the previous population, and then have that be the new population. So I should be able to do this over and over again. So I just want to see if this doesn't give me any errors. It doesn't give me any errors. But this is now running in a loop. The thing is, I'm never going to have an improvement because my new population is just the same as the previous population. So now, here's what I want to do. Here we want to have a genetic algorithm. So what I actually want to do is I want to say the new population is pick from the old population. And I'm going to say, I'm just going to call this var order equal, because I'm going to need to add something called mutation. Pick one from the new population. How do I pick one member of the old population according to its fitness value? The things with a higher fitness, I want to pick more often. The things with a lower fitness, I want to pick less often. I want to just copy the ones that were good and not copy the ones that weren't so good. Okay, so how do I do that? So I've already calculated fitness and normalized it. Oh, I know how. So guess what? I just made another video about this, a particular algorithm for doing that. So I'm going to link to that video in this video. I'm going to link to that video in this video's description. And right now I'm just going to go and grab the code from that. So that code is here in this particular sketch that I programmed earlier today called pool selection. And I'm going to go and grab this function called pick1. Okay, so I'm going to grab this function and I'm going to bring it over to my ga.js. So what this function does is a particular algorithm that I go through. I'm going to describe it to you briefly. If you imagine this as the population, and this has a fitness of 70%, this has a fitness map to probability of 20%, and this has a fitness map to probability of 10%, well, I could draw that almost like as a two-dimensional space with 70% being A, 20% being B, and I didn't draw that very well to scale, 10% being C. So how can I pick a random number between 0 and 1? And whenever I pick from 0 to 0.7, I'm going to kind of land within here. Whenever I pick from 0 to 0.9, I'm going to land within here. And whenever I pick from 0.9 to 0.1, I'm going to land in here. So you can see that 70% of the time, I'm going to land in here. And that's what this algorithm is doing. And I go through it in more detail in the other video. But I do have to make some adjustments here because I'm picking one from this population. And OK, and I think I need two arrays here. So list and probabilities. So I need to pick one from the population according to the fitness values. So I need to just change this r equals r minus probability index, and then return the index value that it finds with that list. So let's see if what this does. OK, and I think I also want to. I just want to make a copy of them. It might be because I'm going to start messing with them. So it's good for me to create a copy of it. So get that order and copy it. So return a slice. OK. I'm not seeing any errors. But again, no improvement. Why is there no improvement? Well, even if I pick better ones more often, if they never change, whatever the best one is only the best one that it will ever be. So this is where I'm going to add a function. And I'm going to call it mutate. So in next generation, I'm now also going to say mutate order. So now I need to write mutate. Oh, and also I didn't. I also have to actually put it in the population, in the new population, which I forgot to do. So let's make sure things are still working when I do that. Whoops. New population equals order. And let's refresh. OK, uncaught error. F is not defined, ga.js line 45. Oh, there's like an extra stray character there. OK. OK, great. So it's working, same problem. Now, so I need to add mutation. What I want to do is add some subtle changes to the ones that I want to take the ones that did really well and just change them a little bit. How am I going to do that? So I'm going to write a function called mutate. And it's going to take an order. And what I'm going to do is, so now we have to think and a mutation rate. So let's think about this. Mutation, so how do I mutate an order? Well, one way to do it would actually just be to take two random elements and swap them. So this order was pretty good, 0, 1, 2, 3, 4, but maybe 0, 4, 2, 3, 1 would be even better. So let's try that. So what I'm going to do is I'm going to say, and I did this already in my shuffle program. I'll do it again. Index A equals floor random order.length. I'm going to pick index A and index B, and then I'm going to say swap order. And remember, swap is a function that I've already written. Index A, index B. So in my mutate function, I'm just always going to swap just one. Let's see how that does. OK, so I'm not seeing any improvement. One thing I realized I probably forgot to do, so let's take a look at the sketch, is I'm not actually, this thing where I check, where do I check? I need to actually check to see if I've got a new best one. Where is that? Did I lose that by accident? Where I went to find the best one? Somehow I lost that. Oh, no, it's right here. Oh, no, it's not. OK. So what I need to do is we have this record distance. So I don't know where that went. I had that coded already. But what I want to do is I want to look at the distance. Did I put that in ga.js somewhere? Oh, it's happening in calculate fitness, actually. So, oh, sorry, hold on. Hold on a sec. Hold on a sec. I don't like the way that I wrote this. I've confused myself. So even though I'm doing it in calculate fitness, I feel like this is a problem. And so I am going to say a separate function called find best. It really makes sense to do it there because this is an expensive operation to calculate the distance, so I'm going to leave it. Never mind. So in calculate distance, it should be finding the best ever. And I should get, and this should be drawing the best ever. So I would think that with mutation, let's just make sure let's make sure this is running. Yeah. So this is doing this over and over again. And let's look at, let's try to debug this. I don't know what I've done wrong here. Let's look at the record distance. So it's finding the same record distance over and over and over again. You would think that through some swapping. So let's take a look. Do I even have like a population, a new population? Yeah, so population has stuff in it. Let's make sure that what's in it makes sense. Hold on. So it wasn't working because I had put in the mutate function, but I didn't uncomment it because I wrote the function and I didn't uncomment it. So let's add that, and now let's see. And I got some console log in here that I probably want to get rid of, or maybe I don't. Let's try refreshing it and see what happens. Ah, yes. So it's getting better over time. Ah, this is working. Look at that. How wonderful. Okay, yay. All right. So now, what have I done? Have I really solved the traveling salesperson problem? I don't think so. So first of all, is this the optimal order? Looks pretty good, but kind of hard to say. Like, wouldn't it be better maybe to go like from here and then there? Wouldn't that be less? But I know it's hard for me to eyeball it. But only way for us to check for sure would be to also have the brute force solution going and have it check every possibility, which I would love for somebody to contribute to this to add that functionality back in. But let's just go to total cities equals 5. And we can see that and let's make the population size, let's make that a variable. And let's make that, let's just make that 10 right now. And so I'm going to put that here. And so you can see it kind of like finding it over a short period of time. Let's make this 6. So we can see that this is working for small numbers. And even with 10, like, oh, that's not, whoa. No, that's the population size. Sorry, and what did I have it at? Total, even with, now with 10 cities, you're going to see like it's doing really, really terribly. But I only gave it a population of 10. So let's give it a population of 300. And you can see with 10, I don't know, maybe is that a good order? No, you could clearly see that you could get a much shorter order by going up those 3 and then across. You can't, my hand doesn't, oh, there, it figured it out. So look at this. Maybe there's some optimization here that could be done. I don't know. So you can see that this is working. And I didn't even do crossover. All I'm doing is mutating, swapping some points in ones that did well. I didn't even make the fitness function an exponential function. So there's a lot of improvements we can make on this. What I'm going to do in the next video, and the way I'm doing mutation is a little bit awkward. What I'm going to do in the next video is see if I can improve this. So this is part 1. I've kind of got something going. I'm going to try to, and I should really, what I would like to do is also draw just the current population's best one down here. I should add that in. So what I'm going to do in the next video is I'm going to try to add some things to improve this, and namely do crossover between 2 orders, which will not be so obvious how to do that, I don't think. I'll have to think about that in between when I hit stop recording and recording. Okay, see you in the next video.